Hi, this is Naveen Nanjundappa. Let us look at the challenges of a spacecraft that is trying to have a soft landing on Moon. You all know that Chandrayaan 2 was a mission where the Vikram lander just failed to land on Moon a few meters away from the Moon surface. We had a lot of uh, challenges that we had to go through, and almost at the last minute, the Vikram lander did not make a soft landing. In today's presentation, let us look at how the soft landing could be achieved, or what are the challenges that one could face when it comes to soft landing. The first one that you will notice is the navigation and guidance error. Every spacecraft that needs to be landing softly would require to go ahead and get an assistance from navigation device as well as the guidance. So you need to have a precise navigation, and the, the instrument has to follow this trajectory. So the spacecraft should know where exactly it is landing, what is the altitude, what is the speed at which it is traveling, and a lot of calculations. But then on Apollo 11, the Eagle module, where you all know the famous man landing on Moon, the lander did not follow the navigation because of some trajectory calculation errors. In fact, that was noticed, and the astronauts in the Eagle module immediately realized that there was a deviation and corrected this deviation manually, which means had they not been corrected, the instrument would have landed somewhere else, or it would have even crash landed. You all know that navigation and guidance is a very essential part of navigating the spacecraft to land softly, and any errors in this could lead to a impact on the moon and can result in hard landing. So the Apollo 11 was successfully landed on moon without any problem. Here is a quiz for you. Please go ahead and look back as to when was Apollo 11 landing on moon. The next one, the thrust busters or the thrusters performance. See, when the spacecraft is trying to land softly on the moon, it has to apply a reverse brake. That is a brake. It has to go through a reverse acceleration. So the thrust busters has to go ahead and speed up in the reverse direction so that the relative speed or velocity of the spacecraft reduces to such an extent that it can reach 0 meter per second as it lands on the surface. In fact, as early as April 11, 2019, uh, Beresheet mission, this was a spacecraft which was from uh, Israel, which was trying to go ahead and land on this. So this actually crash landed. So you can see in this picture the crash landing spot, which was taken up later. But what was the error in this? The thrust busters overperformed, and the the speed of navigation could not be achieved, and the spacecraft technically lost its control and had a hard impact. So it is important that when the soft landing is required, you need to have sufficient fuel and sufficient control over the thrust busters performance. There are usually two or four thrust busters to maneuver the position. Any one malfunction could also lead to a hard landing, and soft landing can become a big challenge. The next one is the thirst, dust and the surface hazards. So the Surveyor 3, way back in April 20, 1967, this was a spacecraft which was trying to soft land on the moon, and they calculated the position of the landing. But then what happened is there was a small crater on which it was landing, and they miscalculated the surface quality. There was a loose soil, and the spacecraft has to land in that loose soil, causing the spacecraft, the legs where the landing has to take place, to sink a little bit. Had it been a little more, then probably it could have resulted in a hard or uneven landing, and the devices might not get sufficient energy from the solar panels, and the mission could have been failed. But in this, despite there was a problem in uh, landing, wherein the one of the legs was sinking into the soil of the moon. It was considered as a successful because it provided a lot of data for the mission. The next one is the communication and data transmission errors. The China's Chang E5, uh, in December 1st, 2020, was trying to establish a communication. So what happened in this is they were unable to maintain a constant communication when this lander started descending its path towards soft landing. Throughout the journey, it was being controlled, but at one point it lost the communication from the main orbiter, and this interrupted the landing. But then later it was found that the landing module had its own calculation and then uh, landing protocol. So that eventually landed on the moon softly, though it was successful. But due to the communication disruption, there was a temporary delay and no information, silence period during the soft landing. Yes, there was a soft landing successful, but then the communication could go wrong as it starts approaching the landing position. So communication and data transmission rate, they're also very important for the soft landing. Then comes the power management or energy management of a system. In Apollo 14, February 5, 1971, the power systems are vital role. They are very important for any of the spacecraft to work on moon. The only source of power could be the solar panels. So what happened in the landing module is the power supply unit failed, and it was the secondary power supply unit, the backup unit, which actually served as a lifesaver on this mission. They had a power saver, and there were people, the human crew, the astronauts had to literally physically change the power supply mode to back to the secondary system. So on this Apollo 14 mission, there was a power supply problem, and the primary batteries failed, and the secondary batteries or a secondary power source was used effectively. Had there been no secondary power supply, the mission would have failed, and the astronauts would have probably been on the moon looking for a life and death situation. Okay. Uh, it was an important learning to have additional power and then go on to the soft landing. The next one is a software failures that could happen in the system. Luna 15, this was a spacecraft way back in July 21, 1969. In this, as the system started descending its orbit towards the landing position on the moon, it observed that there were some malfunctions and software problems that caused the system to basically go in a wrong direction. In fact, there was a critical software failure on Luna 15 mission, and this resulted in uncontrolled um, uh, movement, and that eventually hit the moon surface and caused in hard landing. So this Luna 15 had a hard landing on moon, and it is important that the software that has been written and used should have been tested on all the situations that one can think of for a effective landing on moon. The next one is a site evaluation. In fact, this is an example from Mars mission, the Mars Surveyor 98. This was on September 23rd, 1999. It was supposed to land on a specific location, but selecting a space or selecting a location is a very crucial for the success of the project. It is not just landing on the moon or landing on the space object like any planet or moon. It is also important to know that where you land and in what angle you land. For example, if you land on moon, the moon is going to get the solar energy on one side for 14 days. Now, for example, if you are landing in a different angle, you might not even get as energy, and the system might fail because of the no power. So selecting a suitable land is very important for any kind of soft landing. However, It is not so that every land is suitable. In fact, in this Mars Surveyor 98 mission, when the when the spacecraft was trying to land on Mars, there were land difficulties that was encountered. So there was the dust particles on the Mars surface. This dust particles on the Mars surface gave erroneous numbers or error message error. The numbers were not accurate because of the dust particle or at what altitude the mission is. So the spacecraft has to be measuring its altitude and its descent towards the landing space. Because of the dust and other atmospheric uh, problems or the dust particles, this was for specifically for Mars, not on Moon. The spacecraft had to go through a lot of dust and miscalculation of the altitude, and this resulted in failure in establishing the connection. And later, the the Mars landing was not successful. Okay, so this is one. The next one is a human error. We all know that no matter what happens, the human errors are always there. The second Beresheet mission in February 18, 2021, the spacecraft, when it was about to land on Moon, this was a soft landing experiments by Israel again. So this one, had it been going closer to the space, the landing space, unfortunately, the human error played in. Everything was fine, but the human error played in, wherein the manually the power supply was switched off, and the main engine was manually switched off by mistake by the engineer, and this permanently shut down the system, and the main engine was shut off. So what happened? Since the system shut off, the spacecraft had to do a hard landing on Moon. I mean, you can be thinking about why did this person switch off the system or the main engine? It was a human error, as simple as that. So there could be everything could be right, and then a small mistake by a human or unknown mistake can also unexpected mistake can also lead into uh, a problem with soft landing. Unforeseen environmental issues. The Chang E3 in December 14th, 2013 also had a similar problem. It was supposed to land on Moon, and what happened is the the surface on which the moon the device was supposed to land started sinking, and the lander which was on the surface started sinking more than what expected onto the uh, soil. The moon soil was loose and it started sinking. And this was not anticipated during the site investigation. So you notice that this particular landing was, even though it was successful, but then there were unforeseen errors like the soil conditions was not as we expected, and there was a trouble that was given, and then the whole system had to tilt across and then sink into the soil as it started landing. Okay. Now, let us come to the soft landing Chandrayaan 3. We are hoping that all these missions for soft landing, the error conditions are all considered. In fact, the ISRO chief has already mentioned that Chandrayaan 2 was a mission to land softly on Moon and demonstrate the skills, demonstrate the technology. But Chandrayaan 3 has taken a slightly thought-provoking idea that we are planning for all the problems that we could potentially face for soft landing and avoid all those issues and conditions. So Chandrayaan 3 is more prepared on any kind of soft landing issues, and it is going to maneuver itself to get a better place and location for hard landing. So what are the changes that you would see in Chandrayaan 3? One, Chandrayaan 3 carries two different cameras for tracking and also capturing the images. There are antennas for improving the communication between the lander and the orbiter. There are additional, I mean, the energy or the fuel required for landing has been increased. The space the landing site from 500 meters, square meters, to 2 kilometers, 2 square kilometers has been improved. That is almost like 4 times the previous space. So if there is any problem in the landing place, even at the last minute, Chandrayaan 3 has the capability to move on to a different site, which is much safer and can ensure a soft landing. At the same time, uh, it has also thrust busters or the speed control motors for reducing the speed all the way across four different angles, and then it can actually make maneuver much better. So central thrust busters are removed on this. There are other improvements that are made on Chandrayaan 3 lander mission. Let us hope that Chandrayaan 3 softly land on moon and we will all witness a history being made. Hoping for the Chandrayaan mission success stories. I hope you understood what are the challenges and how ISRO scientists have gone through various different situations to overcome the problems that could be faced in soft landing on moon.